Oops. Hello, everyone, and thank you for joining us today. My name is Matthew Halley. I'm a technical sales engineer at Buckley Associates. I've had a similar role like this for almost 9 years now between Ohio and Massachusetts. And in those 9 years, I've worked for just about any type of commercial project, including labs, hospitals, pharmaceuticals, and any of the R-use buildings we'll be discussing today, including multifamily, hotels, dormitories, etc. At Buckley, I primarily work with consulting engineers in the Boston area. This includes educating engineering community and on emerging and existing technology, as well as providing consulting engineers with package solutions and design support for their plan and spec projects. So this webinar today is just the latest addition to our virtual training center. In fact, this will actually be our 50th webinar that we'll be adding to our library, and we have many more to come this year. In fact, we have 13 upcoming events that you can find on our website as well, so feel free to put them on your calendar and let us know if you have any specific interest in any of those. You may know Buckley Associates as the price and GreenEck reps in your area, but we carry an extensive line card to produce a diverse and complementary single source system for any project. So from air distribution products to mechanical products to the control systems to control those products, Buckley has you covered on just about any HVAC design. So there's a lot to talk. There's a lot we could talk about, but today we're going to narrow it down just to the following manufacturers. So the agenda today involves speaking to the latest energy codes and compliance pathways. That will set the table for discussing the products we have available for these types of projects, like passive house products, the other energy recovery ventilators we have. We have a really exciting system air, high effectiveness DOAS option. We have a lot of other residential products that I'll touch on, including garage ventilation, fire rated air distribution, and airflow and pressure control. And I want to say, because we have so many people attending today, I'd like to hold off on answering any questions until the end of the webinar. You can also feel free to reach out to me or any other Buckley team members with any questions afterwards. We'd love the opportunity to discuss project-specific questions if you have them. So, like I said, latest energy codes. You might recognize this from the government website, and some of you actually might disagree with what you see on the left side of the screen there. It feels like the base energy code in Massachusetts is actually 2021 IECC. Unfortunately, it's actually not yet, or maybe fortunately. If you have a job permitting in the next couple months, you might actually be able to get away with using 2018 IECC, but only for a few specific areas. So here is the Massachusetts code adoption by municipality. And as you can see, base code really does not cover much of Massachusetts. In fact, most of Massachusetts needs to be complying with stretch code, which is 225 CMR 22 or 225 CMR 23. And furthermore, there's a lot of municipalities that require the specialized energy code, which is 225 CMR with appendices RC and CC. So I'm going to get into what that means a little bit more. And just to clarify, yes, 2021 IECC with Massachusetts amendments is going to be coming soon as the base energy code, probably sometime mid-summer this year. But for the most part, we all need to design projects based on usually stretch code or specialized code, which has those appendices that I just talked about. So here's it all right here. This is the mass energy code that we're all need to comply with, and we're going to talk about each one individually coming up here. So in the Massachusetts stretch code, and by the way, let me actually say one more thing. Sorry for going back. The difference between 225 CMR 22 and 225 CMR 23, and along with the appendices, is, and usually I ask this the question if somebody knows this, but residential construction stretch energy code, that refers to buildings up to 3 stories, townhouses, and single family homes. So if you're working on an quote unquote R use or residential use building that's 4 stories or more, that would actually fall under the 225 CMR 23, even if it is for residential construction. So that's the difference, and we're going to talk about each one. So for 225 CMR 22 in residential low-rise construction stretch energy code, the original 2021 IECC section R403.6.1 refers to dwelling units that require an HRV, heat recovery, or enthalpy recovery ventilator in climate zones 7 or 8. So the question is, which climate zone are we? And the answer is, in Massachusetts, we're climate zone 5A. So the stretch code just replaces that section with the following 3 sections. Number 1, you need to have a heat or energy recovery ventilator for a dwelling unit. Okay. Now, in a large system, which is 300 CFM or more, you must have an enthalpy recovery ratio, which is the first time we hear that term, and we'll talk more about it later. An enthalpy recovery ratio of not less than 50% in cooling and at design condition, by the way, 50% in design condition, cooling design condition, and not less than 60% ERR in heating design condition. So that's for 300 CFM or more. Now for 300 CFM or less, you must have a sensible recovery efficiency in SRE, a different metric, of not less than 65% at 32 degrees Fahrenheit, at an airflow not less than the design airflow. 65% at 32 degrees in the design airflow. And note that, by the way, our manufacturers can use linear interpolation of the listed values for SRE. So that's the base code. That's not the base code. I'm sorry. That's the stretch code requirement. But note that in the 65% SRE requirement in the other systems that I just read for under 300 CFM, that might be what the code calls for. But when you do go for a HERS energy rating, the home energy rating index, it will require usually between 70 to 75% SRE. And that's what I'm hearing from the field, just so you know. So moving on to the commercial side of this, the 225 CMR 23, which is the commercial and all other construction energy stretch energy code, there's a few different amendments that are worth noting. So one, it's that in non-transient dwelling units, you should get that enthalpy recovery ratio of not less than 50% in cooling and 75% in heating. So in the winter, you must get basically a higher enthalpy recovery ratio. And one of the really big differences here is the next section, which is spaces other than non-transient dwelling units. So an enthalpy recovery ratio of 70% in heating and cooling must be required for the entire building, basically. Now, that's different than it used to be. This is a big change because it used to be that you could get away with a lesser cooling ERR than the heating, and now you need 70% ERR in both heating and cooling at the design conditions. So a couple more amendments that are worth noting, just because they have to do with the equipment that we sell. There's a points-based system on C406.1 where you used to be able to get away with 10 credits in the points-based system, but now you need 15 credits. And the easiest way to achieve those 15 credits is actually using the renewable space heating. You get all 15 credits if you use basically an air source or water source heat pump that can give you a coefficient of performance, or COP, of at least 1.75 at 5-degree source air, ambient air. Okay. So that's stretch code. Now let's move on to stretch or specialized code. Within specialized code, there's not too much that they add except the pathways. The changes to the pathways are the most significant. So in a 225 CMR 22 residential low-rise construction stretch energy code, specialized code, I should say specialized code. Basically, you can get compliance under 12,000 square feet with HERS 45 or 42, and there's one option, and if you look at that grid there, where you can get HERS 0. But anytime, as soon as you go past 12,000 square feet, you have to use Passive House, and that's what FIAS is referring to, Passive House Institute, United States. So Passive House is going to become a pretty common theme and I think most of the people tuning in now probably understand what I'm getting at. Passive House is really the main pathway we'll be talking about in any specialized opt-in code regions. So same with the commercial space. You know, in any commercial buildings like 225 CMR 23 commercial and all other construction, specialized energy code gives you three different compliance pathways. One, zero energy means your renewables, or essentially your solar that you have on site, must make up for any resource use you're using on site. Number two, everything is just all electric. And number three, you can get a mixed fuel pathway where you have pre-wiring for future electric. However, as soon as you bring in the consideration of R use, and it uses this term right there on the 12,000, sorry, the 12,000 square feet, you have to use passive house. You can see right there, you were able to get away with a targeted performance or HERS index compliance pathway prior to January 1st of this year. But now every size building above 12,000 square feet must require passive house. So what is passive house? Oops, sorry. So what is passive house? All right, this isn't working. Ah, there we go. Passive house is, well, first of all, passive house is a compliance and energy modeling metric that's come from overseas, really. That's kind of where a lot of the adoption occurred originally, but we are getting the United States version of it. And one thing I don't list here is that the energy model that goes into a passive house compliance includes a WFI model. It's just the energy model required to get to and finalize your prescriptive checklist. So those checklists, by the way, and our stretch code and specialized code identifies it. The C407.3.1 compliance says buildings shall be pre-certified as meeting the FIAS Core 2021 or FIAS 0 2021 passive building standard. So within that standard, you know, hearing from the engineers in the street, they basically have said, you know, you can get an absolute minimum ERV performance requiring 75% SRE, but it'll likely be up to 80% SRE. That's just sensible recovery efficiency that I mentioned earlier. So one other thing required from our equipment is that it must have EC motors. It's really just those two. When it comes down to it, our equipment is required to be more efficient and requires EC motors. So, and you know, that WFI model really will determine the type of equipment you can use, but basically you're going to end up needing a much higher efficiency ERV. So beyond that, FIAS, passive house, is mostly about envelope and construction quality. A lot of the work is really coordinated with the architect to make sure that the envelope is tight. So at the end of it, you actually need to meet an envelope leakage test, and that'll come in play later when I have to talk about a product. So this is kind of my, so far, most of the code review, and I'm going to start moving into what type of products we have to accommodate this. So right away, we have a brand new passive house product from American Aldi's. It's called the Inspirator Top, and it is up to 80% SRE, like I just said. That does have EC motors, and it comes with that ERV counterflow core that everybody's been talking about because it can get more efficiency out of it. It's really quiet. It's easy to install. You get pretty robust ventilation capacity. And one of the really cool things about this is you actually get, you have some options with the filter, which is topical recently, obviously, but you can get MERV 13, 15, and actually active charcoal options within that filter. And this is a passive house certified unit. And that PHI, that sticker down here to the right, is it's more relevant in the European market because they actually have to have the PHI certified components. But it is good to know that, you know, this is intended for passive house projects. So along those lines, we also have a really exciting DOAS option called from Systemair. We've been working with Systemair for a long time. Buckley has since our inception to some capacity, and they're, you know, a really big company that deals with a lot of markets, and we are now excited to have their DOAS line. So that's the Geniox unit, and it ranges from 440 CFM all the way up to 65,000 CFM. We can integrate this with any VRF system, but If you reach out to us, we'll likely work with DCNE with their Carrier Toshiba VRF system. But again, if you're sold on a specific VRF system, we're happy to provide the components that you can, mount any VRF coil and it'll work with that. So this unit will achieve up to and actually beyond 85% enthalpy recovery ratio. This will really help average out your total enthalpy recovery ratio of your building. And it does that with a high effectiveness wheel. There's a Kinsenberg wheel, I believe it's called a Kinsenberg wheel, and you can use that, or you can do a counterflow core, and we can also even do a glycol loop, glycol coil in this unit for those Type 3 or 4 exhaust. Which, by the way, in Type 3 and 4 exhaust, and I know we're not talking about that in residential capacity, you need to get a 50% sensible recovery ratio for those systems. So if you do have a lab or really just a lab application that you want to consider using something like this, let me know. This is a 60 millimeter double wall cabinet, which is just greater than 2 inches. We can do all American supply voltages and at 60 hertz. So that means 483 phase, 208 phase, doesn't matter. This actually comes as a modular design, so it's really easy to install in a tight space if you need it. So we can install this unit indoor or outdoor, and it's intended for outdoor, but there's no problem mounting it indoor. And like I said, it's modular, so you can piece it together on site if you need to. So along those lines, this is more from System Air, and these are all indoor units. This is the false ceiling unit and the standing unit. So between 400 to 4,000 CFM, we can get much higher, very high heat recovery from it and energy recovery. And that's using both counterflow or rotating wheel ERV options. And all of these, by the way, are also VRF integratable. So here is a very interesting unit back to residential design. This is kind of like an all-in-one vertical fan coil unit where the ERV is actually integrated into that vertical fan coil unit that would be inside the residential space. So we have an updated, and if you don't know about this, we've had this for a little while now. We've had some really successful projects integrating both heat pump and VRF, as well as 2-pipe, 4-pipe, DX, and hot water, both NSF and central hot water. But as I stated earlier, a lot of these projects are going all electric, or to, I should say, renewable space heating. So the heat pump and VRF option have become very popular. And recently we have redesigned this unit to have a higher efficiency. So we can achieve a pretty high enthalpy recovery ratio in heating and in cooling. So greater than 80% ERR in heating and cooling. And that's at the design conditions. You can see there to the bottom left. That's at the design conditions that engineers like to design to in Boston. And yes, that means 0 degree outdoor air. So a couple other things that we've added. We've actually paired it up with the new Carrier MURA heat pump, which means we can have the cold climate and COP minimums that we require in our territory. So it's also got a little bit wider footprint than it did. It's 24 by 20 now, which means that your total clearance is going to be 32 by 23. So just let us know if you have a design like this, and we'd be happy to help configure it for your application. So for projects like this, we usually integrated an ERV like this to be piped into a vertical fan coil unit. So we still have those options, and we have many options, some from Reverse-O-Matic, Aldi's, and GreenHack. I put dollar signs up here just to give you an idea of kind of how we like to handle these projects. We have really all performance ranges you need at this size. It's typically used in like a low-rise residential option. So, but we can hit your performance metrics and give you a cost-competitive option here. Now, typically these units for the new code, you wouldn't necessarily get the ERR value you want to at the design conditions, which is why I'm bringing up now some different options from American Aldi's actually. So all of these options here, they are all configured to work with our conditions in Boston. These units do meet the ERR values that we require by the stretch code, and these are all based on, so like I said, summer conditions are 91, 73 dry bulb, wet bulb, and winter conditions includes 0 degrees outside air. So these can be used in your woofy model if you're doing a passive house application, and these would be these would work for your passive house application. Oops. So another really amazing product that we have coming out is, well, this has actually been popular in our market for a while now, but we have some updates that I'm excited to share. And to be fair, these are a little ways out, but in May of this year, we'll be able to provide the GreenHeck RVE option with an updated air source heat pump. And that heat pump will work with 0 degree outside air. So that's an air source heat pump up to 70 tons, and we'll actually be using this with the new refrigerant. We will next January will require an A2L refrigerant, and GreenHeck will be providing this with the R454B refrigerant. So that's great because you can hit an airflow range between 500 CFM to 18,500 CFM, and you can usually achieve an enthalpy recovery ratio from an RVE unit with between 70 to 80%, and that's with an enthalpy recovery ratio wheel. So this unit we've been selling for a long time in this market, and we're excited to say that it's going to be updated for our market, and we'll be able to really go for any projects that we'll typically be releasing after August 5th, just so you know. So along the lines of residential products, let's talk about wall penetrations. Reverse-o-matic makes a wall penetration that we find to be a quality unit, something the architect would like. And typically, and this would relate to our ERVs that we were just discussing, inside the unit ERVs, typically the exhaust and intake need to be spaced by 10 feet, right? That is what code has always said, but coming soon, we will have the 2021 IMC verbiage from section 401.4 about intake opening location, where finally separation is not required between air openings and living space exhaust air openings of individual dwelling unit or approved factory-built intake exhaust combination termination fitting is used to separate the air streams in accordance with the manufacturer's instructions. So the question is, what would be acceptable, right? What would be acceptable to the point that you can not separate those exhaust and intake fittings? Well, our idea so far, and to be fair, it hasn't been adopted yet, but our idea is that ASHRAE standard 62.1 should have a say here, where that dictates that energy recovery devices rated for less than 10% cross-contamination can return restroom exhaust through any device. So basically, as long as you're not re-entraining 10% cross-contamination, then it should be fine. And actually, New York City has already adopted 2021 IMC, and they've actually given this interpretation some validity in their administrative code, Title 28, Section MC 501.3.1, where it said they have already carried over that 10% cross-contamination network metric. So this is what it looks like. This is the DVG model. In this model specifically, we only recirculate 2% of air at 100 CFM. So, and by the way, we have third-party testing to back that up. And there's some really great details about this, but there's a few different options too. So if your architect is sold on a specific look, we can do that. If they want a vertical look, we can do that. We have a few different options, and all of them are third-party recirculation tested. They use a gas tracing technology. You can see the setup there on the left. And basically, the good thing is, and by the way, we have a wind speed across this up to about 15 miles per hour. It's 23 kph, where the unit is tested at different flow rates between 100 and 60 CFM, which is pretty common, and none of them even meet half that 10% requirement. So we feel like we have a pretty good option here for this, and the best part is we actually have a detail that you can use on your drawings. We have a PDF and DWG file available for this unit, and along the lines of what I said earlier about the envelope leakage test, right? This detail makes it very clear how to seal this properly. You can caulk vent all four sides. You and basically, you know, as long as you carry this detail, you should be fine with the actual leakage of this unit in the envelope. So along those lines, you might not be doing a compartmentalized ventilation design, and you might be using a riser, and we still have a lot of great options for those types of designs as well. Our American Aldi's constant airflow regulator, the CAR 3, it's a modulating device that automatically regulates airflow to constant levels. And you can actually adjust it right in the face of that. So as long as you're delivering a constant pressure across that unit, you will get the airflow you've designed it for. And we can use this device in a lot of different ways. We can put it in an exhaust register, we can put it in an exhaust boot or supply boot, and we can even put it in a zone register terminal that will help you modulate between an airflow and shut off, or between minimum and maximum airflow. And the way that works is you basically, here's an example of our fire rated version. By the way, all of these units can be fire rated, the boot, the register, or the ZRT. And the difference can be seen here. You can actually see that the damper assembly. When the damper assembly closes, you shut off airflow to that unit, and when it's open, you're getting the flow that's from the constant airflow regulator in the neck. Alternatively, with a ZRT2, you can get, when that damper closes, you're getting the airflow in the damper, which will be your minimum airflow, and then when it opens, you'll be getting the maximum airflow. So this can be used for demand control ventilation in a riser type design. Along those lines of fire rated air distribution, we have a really great detail at Buckley that we can use on any of your projects that are involving wood frame construction. It's really important to understand that when you are designing a space, you can't use a standard diffuser and put a thermal blanket over top of the back of the diffuser and then have a CRD in the neck. That will not be a UL compliant assembly. What you need to do is actually apply a ceiling radiation damper boot, like you can see here, and then actually have your supply diffuser in the face of that, so that there's no wood exposed to the heat that could happen from a fire. So we have a really great option here where we can put a full price LCMD with an OBD, opposed blade damper, in the back of it, so you can get volume control, you can get a nice quality diffuser, and you can meet your UL expectations in that assembly. So let me know if you need something like this. It's really easy to put on your drawings. So moving on, other residential products that we have available from System Air, we have garage ventilation jet fans. So these jet fans are really amazing. They're only 6 inches deep, and basically they replace all of your ductwork throughout your garage. So using ductwork in garage to ventilate the space is actually pretty antiquated. What you end up with is a lot of dead zones where CO and NO2 can build up. And what this does is it actually pushes the air from the intake to the exhaust. And if you don't believe me, we have CFD analysis available to prove that. And we do a lot of these projects. This is actually one of our most successful products that we've brought to the market, and we do quite a bit of them. Your intake and exhaust code wouldn't change. It's just the way that you're pushing the air from the intake to the exhaust. And so let me know if you have anything like that. And along those lines, we have a lot of great gas detection options, but one of them from Intech, which is an electrochemical, which is a very electrochemical technology, which is a very robust, and it doesn't drift very often. Basically, it's a very robust option for gas detection. We have a gas detection specialist at Buckley as well. So if you have any projects where you'd like both this garage ventilation layout, and actually a layout that we can lay out all the different sensors throughout the garage, please let us know. And along those lines, if you're doing a project that we were talking about earlier, where you have and this would be especially useful in a VRF application, we have refrigerant leak detection available as well. ASHRAE 34 has established basically a refrigeration concentration limit, and VRF systems usually require detection. This is a great insurance policy for your owner end user, and it's definitely something worth considering putting into a space where gas refrigerant can build up and become a problem. Moving on, we have some really good dryer exhaust options from Reverse-O-Matic and GreenHack. If you're doing something small like a 1-to-1 dryer exhaust booster, we can do that with Reverse-O-Matic, and then with GreenHack we can do multiple dryers on a common system. So what I have here is kind of like the small, medium, and then we also have a large option as well with LFS systems. So LFS systems, they do really, we can do anything from, I guess, a small CFM, small laundromat or laundry system, all the way up to a large laundromat. And one of the cool things about this L150 controller is that we can actually have a current sensor input on it as well. So it can operate on pressure, but be activated as soon as that dryer turns on. So I think we're going to look at some questions now, but let me see. I'm not sure how we're going to do that. Lindsay, do we have any questions? I don't see any questions. Okay, so if you do have any questions, please feel free to reach out to me or any of your Buckley representatives that you know. We'd be happy to reach out to you about any questions you have. So I appreciate your time today. Thanks for attending.